guys, so let's look at the pumping action of the heart. The pumping action of the heart. You see, the heart undergoes two events, and they are contraction and relaxation. Contraction is also known as systole, and the heart actually undergoes contraction to pump blood to the various parts of the body, especially, or to be specific, the ventricular chambers. They undergoes contraction and pumps blood to the other parts of the body through the pulmonary artery and the aorta. So the right ventricles pumps blood through the pulmonary artery to the lungs, and the left ventricles pumps blood through the aorta to the heart, to the whole part of the body. When the heart pumps blood to the blood vessels, when the heart pumps blood to the blood vessels, you know that now the blood are in the blood vessels. These blood, they will exert certain forces on the walls of what? The blood vessels. And these forces actually constitute what we call the pressure. You understand? So the higher the force they exert on the walls of the vessels, the higher the what? The pressure. You understand? So high force gives us what? High pressure. So let's consider this scenario. When there are a lot of blood in the blood vessels, you see that because there are a lot of blood in the blood vessels, the blood will exert more forces on the walls, and that will lead to what? High pressure. And this happens during heart contraction. When the heart contracts, it pumps a lot of blood into the blood vessels, and that increases what? Pressure. And that pressure is called systolic pressure or contraction pressure. You understand? So the pressure in the blood vessels after contraction are called what? Systolic pressure. And when the blood vessels are very little in the blood vessels, because they are very small, they can't exert much force on the blood, on the walls of the blood vessels, and thereby the force in the vessels becomes low, and low force will give us what? Low pressure. And this scenario actually occurs during the relaxation state of the heart, the diastolic state of the heart. So this pressure in the blood vessels during the relaxation or the diastolic phase of the heart is called what? The diastolic what? Pressure. So now let's look at relaxation. Another name for relaxation is what? Diastole. And the heart actually relaxed to allow the heart to be filled with what? Blood. So when the heart relaxes, it allows the heart to be what? To be filled with what? With blood. And note that the blood actually first filled the what? The atrium before what? The ventricles. And when during the atrium filling, these valves, the tricuspid and the bicuspid valves, are being closed. This to allow the atrium to be filled before the ventricles. You understand? So after the filling of the atrium actually contracts. The atrium actually what? Contracts. And some of the blood in the atrium are being pumped into what? The ventricles. 30% of what? The blood in the what? In the atrium are being pumped to the ventricles during atrium contraction. The other 70% falls passively into the ventricles when the valves are being opened. You understand? So during the atrium contraction, note that these valves, they have to open. The tricuspid and the bicuspid valves, they have to open. And 70% of what? The blood falls to the what? The ventricles by gravity or passively. And the other 30% are being pumped into the what? The ventricles during atrium contraction. Put that in mind. The amount of blood in the ventricles, after relaxation of the heart is called the end diastolic volume, and it is averagely it is 120 milliliters. After the contraction of the heart, to be specific, after the ventricular contraction, some of the blood are being left in the what? In the ventricles. Not all the blood are being pumped. Some of them are being left in the ventricles, and those blood left are called what? The end systolic what? Volume, and it is averagely what? 50 ml. Hope you understand. Sure. And now I want you to note something here. During ventricular contraction, when the ventricular chambers are contracting, note that the bicuspid and the tricuspid valves are being closed. This is to prevent blood from flowing back into the what? The atrium. You understand? It prevents blood from flowing back into the what? The atrium. But rather, the pulmonary valve and the aortic valve opens during ventricular contraction, because the ventricles contract to pump blood through the what? The pulmonary artery and aorta to the other parts of the body. So the gates have to open so that for blood to what? Flow. You understand? So the pulmonary valve and the aortic valve are being opened, and the bicuspid valve and tricuspid valve are being closed during what? Ventricular contraction. During relaxation of the heart, the opposite occurs. The bicuspid valve and tricuspid valves open for the blood in the atrium to get into the what? The ventricles, and the pulmonary valve and the aortic valve closes. You understand? Yes. So during relaxation, the opposite of what I said first occurs. So now let's look at the cardiac cycle. When your heart rate is 70 beats per minute, how many cardiac cycles does your heart make? The answer is 70. So this explains cardiac cycle. You understand? And one thing you must note, that blood actually moves from what? High pressure to what? Low pressure. Blood actually moves from what? High pressure to low pressure. And let me explain something here. Whenever something contracts, let me use the blood vessels to explain. When the blood vessels contract, that means the diameter of the blood vessels decreases, and now the blood vessels in it will exert more forces on the walls, and that will increase what? Pressure. So whenever there is contraction, there is increase in what? Pressure. When there is relaxation, there is decrease in what? Pressure. Hope you understand. So I said here that contraction actually increases what? Pressure. It is not only the blood vessels that actually does this, but also the cardiac walls. You understand? When the cardiac walls contract, you see, when they contract, now the walls will attach to the blood. You understand? And now the blood will exert more forces on the what? On the walls, and increase the what? The pressure. You understand? So this cardiac cycle starts with, let me write it. It starts with atrial contraction. Atrial contraction. And during atrial contraction, this bicuspid valve, this tricuspid and bicuspid valves open. During atrial contraction, this tricuspid valve and bicuspid valves open, whilst the aortic valve and pulmonary valve are closed. And during atrial contraction, 30% of the blood in the atrium are being pushed to the what? To the ventricles. Are being pushed to what? The ventricles. And you see, the key word here is contraction, atrial contraction, meaning that the atrial walls are contracting. And when they contract, their walls will attach to what? The blood inside them. You understand? And the blood will exert more forces on what? On the walls. And when they exert more forces on the walls, they increase what? Pressure. So the atrial pressure increases. And because the atrial pressure increases and becomes greater than the ventricles, the blood flows from what? The atria to what? To the ventricles. You understand? So during atrial contraction, the blood flows from what? The atria to what? The ventricles. 30% of the blood. The other 70% falls passively by gravity without any contractive force. They fall on their own by gravity. Yes. So after the atrial contraction, now the next phase I'll talk about is called the isovolumeric contraction of the ventricles. So the isovolumeric contraction of what? The ventricles. During the volumeric contraction of the ventricles, the ventricular walls actually contract slowly. They contract what? Slowly. And actually the walls of what? The ventricular walls actually touches what? The blood. And now the blood will exert more forces on what? The walls of what? The ventricles, thereby increasing the pressure. But this increase in pressure is what? Slowly, gradually. So they will contract and be pulling the blood in them, upwards. So they will pull the blood in them upwards. So the time that it gets here, you understand? When it gets here, it's actually, note that this part is also undergoing the same thing, the same process. You understand? So they push the blood upwards, and it causes the tricuspid and the bicuspid valves to bulge into the atrium. You understand? When they bulge into the atrium, they slightly increase the atrial pressure. Let's put that one aside. That's just for extra info. They slightly increase the atrial pressure when the valves bulges into them. Understand? So the contraction will slowly increase the pressure in the ventricles till a point is reached where the ventricular pressure, you see the ventricles, they are pumping blood to the aorta and the pulmonary artery. So the pressure in the ventricles increases to a point where the ventricular pressure becomes greater than the aortic pressure and the pulmonary pressure. The aortic pressure is approximately 80 ml per mercury, and that for pulmonary is 10 millimeters per mercury. So the pressure in the ventricles increases to a point where their pressure actually exceeds the pressure in these blood vessels, the aorta and the pulmonary trunk or artery. Understand? So when the pressure exceeds them, now blood is being ejected into them. So blood is being ejected from the ventricles to these blood vessels. You understand? These blood vessels. So that phase is called ventricular ejection. You understand? So the blood are being injected into these vessels. When the blood gets into these vessels, and during the ventricular ejection, note that these valves will open so that blood can flow, but the bicuspid and tricuspid valves still remains closed. You understand? It still remains closed. And when the blood gets into these vessels, the aorta and the pulmonary artery, note that now there will be a lot of blood in them, and now the blood in them will exert more forces on their walls. You understand? And that will increase pressure. So the aortic pressure and the pulmonary artery pressure increases, whilst the ventricular pressure decreases. You understand? Whilst the ventricular pressure decreases, because now the amount of blood in them is very low. You understand? So the force that they will exert on the walls decrease. You understand? And that phase where there is increase in aortic and pulmonary pressure and a decrease in ventricular pressure is called the isovolumeric relaxation. Isovolumeric relaxation. Understand? I made mention of isovolumeric contraction. During that phase, the volume of the volume of blood in the ventricles remains the same. It is only the contraction that increases to increase the pressure, but the volume of blood in them remains the same. That's why we call it isovolumeric. And here too is isovolumeric relaxation, because the volume of blood in the ventricles remain the same, but just that the pressure that drops due to relaxation. You understand? So after the isovolumeric relaxation, there is what? Atrial and ventricular relaxation, and that allows the atrial to be filled with what? Blood again, and the atrial will undergo atrial contraction to pump blood to the ventricles, and the whole thing starts again. You understand? So that's for what? Cardiac cycle. Let me use this diagram to explain. This P wave here represents the atrial contraction. When the atrial contracts, these P waves actually represent the atrial contraction. And this QRS wave represents ventricular contraction. Combination of the isovolumeric contraction of the ventricles and ventricular ejection. So this QRS wave represents that. And this T wave represents ventricular relaxation. It represents ventricular relaxation. Yes, to allow the ventricles to be filled with blood. So that's all. And now let's look at blood flow. Normally, blood actually flow in layers, and that kind of flow is called laminar flow. You understand? And that flow is very silent. You understand? And because they are flowing in layers, the velocity of blood is very high in the middle. You understand? The maximum velocity is at the center. You understand? And the minimum velocity is at the ones close to the walls. You understand? So the velocity decreases from the center to the walls, and even gets to a point where the blood that are very attached to the walls. Let me take that again. So the velocity actually decreases from the center to the walls and gets to a point where velocity is 0. You understand? The blood flowing that is attached to the walls, they have their velocity to be 0. You understand? So that's laminar flow. And the blood flowing that are close to the walls have a low velocity because of the resistance that the walls exert on the flow. You understand? But in the center, the blood is free and moves with high velocity. You understand? Let's say that there is a plaque in the blood vessels. When there is a plaque in the blood vessels, this is pathological. When there is a plaque in the blood vessels, now the blood flowing, you see, the laminar flow will be destroyed, because now the blood flowing here will hit this plaque, and now the direction will change. When they hit, and now they'll be traveling or moving in different directions. You understand? They'll be traveling and moving in different directions, and this is what we call the turbulent flow. And when there is backflow of blood, this is known as memo or bruitize. When there is backflow of blood. And the backflow of blood starts from the turbulent flow, and some will move backwards and cause memo or bruitize. You understand? This memo or bruitize can be caused in certain diseases. You understand? You can look at them. Yes, so that's all.